in figure O is the center of a circle of radius 5 centimeter. So we have this circle and this is 5 centimeter. Let's add that information to the diagram. Then we have T is a point such that OT is equal to 13 centimeter. So this is 13 centimeter. Then what do we have? OT intersects the circle at E. Means what? OT is a straight line. So we have E is one of the points. Actually OT is also given over here. So its point on the circle is one of the points is E. Other point is P and the other point is Q. If AB is a tangent, or we have AB also to be the tangent, there is one more external point other than T. Agree? It is similar to the question that we have done before, but it's a bit lengthy. That's what I think. Let's see how much the writing will happen. Find the length of AB. So as usual, we know the length of TQ will be same as TP. AB will be same as AP. BE is same as BQ. So all of that will be useful. So I don't know exactly how much writing part will happen. I think it will be a bit lengthy. So since we are trying to find the length, so we need to take up this to be 90 degree. Simple reason being we have to use Pythagoras theorem quite a few different places, I feel. So this is also 90 degree. Other end everything else is 90 degree. So pretty much everything over here is 90 degree. What else? We can take this as X. This looks like X, but I'll just, as of now, I'll just take it as Y. This is also Y and that's also X. Okay, guys. So now the working. So what do we have? We have, what will we start off with, guys? Let's talk about angle OPT. OTP. And also we have angle OEA is equal to 90 degree. Why is all this? This is because of the reason that, for the fact that we have the radius being perpendicular to the tangent at the point of contact. Okay, all this is well and good. What is the next thing? We can find out PT. We'll go systematically. So let's find out PT first. So in triangle OPT, we have as angle OPT is equal to 90 degree. Okay, which we have already written actually. It's no point in writing it again. Right, we need to reduce the walking. So we have OT square, that's the hypotenuse, OP square plus PD square. Right? This is 13 square. This is 5 square, I guess. Yeah. And PT square. Oh yeah. The reason being Pythagorean theorem. So we have PT square is equal to 169 minus 25. And we have PT is equal to square root of 144, which is 12 centimeter. Okay. So this we can add it to the diagram. So writing diagram for big answers is a norm. So you guys have to, even though it's given, we'll end up writing the diagram. A rough diagram, but still writing a diagram is must as per the rules. Okay, now let's figure out which one X and Y values, so on and so forth. I think that is what we have to end up with. Can I do anything about? We can do one more thing. We can find the length of ET from the triangle ETA. Okay, so let's think about this. So we have this triangle. So we have this to be see here we have a 90. We have ET to be of 8 centimeter. Can you guess why? Simple. OA is 5 centimeter. So we know two sides. We can find AE. Is it not? Okay. So we have. No. Wait. Oh yeah. We can find it actually. Guys, simple. We have AT is equal to what? AT is 12 minus x. And we have this to be x. And this is 8 centimeter. And using Pythagoras theorem, we will be done with it. It's not a big answer actually. So first of all, we'll talk about length AT. See, AT is PT minus PA. So this will be 12 minus x centimeters. Right? And then next we have, that's AT. Then we have, oh yeah, I need to explain why is that. I didn't explain it. No. We can't jump to this directly. First thing first, we'll talk about PT being equal to TQ. Okay, both are equal to 12 centimeter. Reason being tangents from an external point. And next we have, what else do we have? We have AP. We'll assume AP to be, let AP or PA to be equal to x. And we'll also call, or we call AE to be equal to x, I think. That doesn't matter actually. And EB to be equal to y. To be honest, AE and EB are of same length, but again, I think I discussed this. We have to prove that. So therefore, we have with D as an external point, or D, sorry, A as an external point. What is that we're looking at? With A as an external point, we are looking at AE is equal to AP. Both of them are equal to x. And then we have with, I think therefore it's not required over here, with B as an external point. So we have BE is equal to BQ, which is equal to y. Again, try to observe it. It's quite simple. Here is the external point and the lengths touching the circle from this point to this point. Okay, and now we can talk about AT being 12 minus x. AT, which is equal to AP minus PT, which is equal to 12 minus x. Is that correct? AP is no. PT. This is PT minus AP. And then we have the other end. No, not required actually. I think we are done. Okay. Should we do that or not is something that I'm thinking. Oh yeah, I have to talk about ET also. Let me copy this. I think we need it next to us. We'll need that. And now on to talking about which side. We are talking about ET. So ET is equal to TO, the entire length, minus OE. So this is 13 centimeter minus 5 centimeter, which is equal to 8 centimeter. Then what else do we have? I think we're almost done. Yeah. Now we'll consider triangle AET. So we have ET square, which is equal to AE square plus ET square. Reason being because angle AET is equal to 90 degree, and I think we already stated the word Pythagorean theorem, and yeah. So we are done with that. So 80 is what? 12 minus x the whole square. This is AE is x square plus ET is 8 square. And for the calculation we have A minus B the whole square, which is equal to so on and so forth. This is 144 plus x square minus 24x is equal to x square plus 64. So we have x square getting cancelled, rearranging, and we have 24x is equal to 144 minus 64. So this says 80. Is that correct? This is 0. This would be 80 itself. Yeah. So x is equal to 24. And so this is 20 by 6. Oh, it goes no. 6 4 is 24 and 10 by 3. So x is of length 10 by 3 and this entire length will be of 20 by 3 length. But yeah, we need to prove that. So for that, again, we have to go to the other side and so on and so forth. We can just tell similarly. Let me kind of cancel this. So now we have at the other end, what do we have? Similarly, we can prove y to be equal to 10 by 3. And therefore, AB, I guess, is combination of x plus y, which is 2 times of 10 by 3, which is 20 by 3 centimeter. That's it. That would be your length of AB.